morning, everyone, and thanks to KTN for this opportunity. I'd like to talk to you. I've got 15 minutes this morning to talk to you about some primary research we did. XMOS is a semiconductor company that's headquartered in the southwest of the UK. Our focus is on the artificial intelligence of things, so providing solutions for the artificial intelligence of things. And we were interested to try and understand the sentiments of the engineering community, and when they were faced with the challenge of delivering on the various different aspects of the AIoT in order to really capitalize on the opportunity. So I'm going to spend a few minutes going through that with you this morning. So firstly, just to sort of set the scene and the reason why everybody is so very interested. I mean, we're all very familiar with how quickly our digital lives are evolving. It may be perhaps a surprise to some that since COVID has been on the scene, actually I think it's been an accelerator. We've seen various different digital technologies, the evolution of them accelerating somewhat faster as a result of our new normal. We've seen certainly also technology and devices becoming smarter, and we are entering a new era that doesn't just promise a connected world, but and promises intelligence that gives us the ability to make our lives simpler, safer, and more satisfying. So the AIoT is a convergence of two, what I would call meta markets. There's artificial intelligence, which has been very prominent in the news for many years now, and also the Internet of Things, which describes a ubiquitous connectivity between all sorts of products, very fragmented collection of markets with products that all connected together through the internet. So this is a huge opportunity. The convergence of these two massive markets is a huge opportunity. In fact, Gartner, these numbers are from Gartner, but one number that's not on this slide is that Gartner predict next year that 1 million devices that are augmented with artificial intelligence will be selling every hour, which is just staggering. So we wanted to, as a company, we wanted to explore what the challenges were to delivering on this promise, and so we commissioned some primary research to dig a little bit deeper into the thoughts and sentiments of the engineering community. So the research was 200 electronics engineers. As you can see, they came from various different parts of the semiconductor business, with various different care-abouts, and we asked them their views on the technology building blocks, barriers holding the market back, and their own design and commercial priorities. So over the next few slides, we'll talk through some of the key findings. One of the things that's interesting to me is that when you survey engineers, you're not surveying the group of the cohort of people that are primarily interested in really pushing the boundaries of possibility, the visionaries that sort of express what the world might look like in 20 or 30 years' time. You're talking to people that are actually responsible for turning those visions, turning those concepts into reality. And engineers are a pretty discerning group. So you get a sense of where we are on the hype curve. And our research shows that the engineers are acutely aware of the potential of the AIoT. 40% is a big number in a survey like this, particularly when you consider that that's the prediction of the AIoT radically changing technology for the better. And even more so, engineers saying that the AIoT is critical for improving the way that we interact with technologies. Now, in some ways, obviously, people respond as people, as well as members of a certain cohort, and we're all very aware of the hijacking, if you will, of the previously somewhat unintelligent wireless speaker and its transformation into smart speakers. That's part of many of our everyday realities, and that's just a single demonstrator, the thin end of the wedge, if you like, of how intelligence is going to proliferate into things that we find in our everyday environments. So this set of results gives us a sense for the attach rate, or for the anticipated attach rate of AI in various sectors. It's a healthy attach rate. It's interesting. It's between 20 and 40%, but I think this actually probably shows some conservatism. And there are various industry commentators talking about this phenomenon. The most recent one I saw was Dr. Naveed Shawani, who's in fact at the time was the president and CEO of Sci5. Now he's the chairman. He showed a study that by 2025, the attach rate of intelligence to end devices, endpoint devices, would be 100%. So whether it's 20%, 40, or 100%, it cannot be ignored. Over 80% of our respondents said that AI will increase their competitiveness, and the prizes on offer in the semiconductor industry are huge. The semiconductor market today is just under $500 billion. So there's a significant potential for those that can harness AI and deliver on that that promise of additional competitiveness. So amongst the people that we surveyed, we're pretty confident to say that they care about this issue, and many of the engineers, I suspect, are thinking very carefully about how they deliver on this, and possibly already involved in projects in this space. So let's take a quick look through some of the devices and what they might look like in our day-to-day lives. Starting in the home. The home's perhaps the most familiar use case certainly in today's world. The primary advantages are about convenience, but also increasingly safety. A classical example is the kitchen. Voice interfaces continue to be one of the primary deployments of artificial intelligence at the edge. And voice interfaces are really good at adding convenience where you've got busy eyes, busy hands. In the kitchen, you might have just been cutting fresh meat, so there's a hygiene challenge. They might be covered in flour, so you don't want to touch your technology or your appliances. Or it might be you're simply multitasking. You're doing multiple things, and you want to set a timer, or you want to switch off a hob or something of that nature. Primarily about convenience. What we're seeing emerging now, though, is the safety aspect as well. To stay in the kitchen for a moment, we can do human presence detection, so we can control the availability of appliances, but we can also detect whether or not the human that is present is a child or an adult. And if there aren't any adults in the room but children are present, we may choose to disable the oven, for example, or disable the hob, or disable the ability to close the door on the washing machine, for example. So those sorts of use cases are becoming very, very accessible. And increasingly, we're also seeing technologies that allow the elderly community to age in place. So looking after people that might be living alone, that perhaps have mobility issues, drug regimes, things that are complex to manage, that can be managed using this type of artificial intelligence deployed in the home. So lots and lots of use cases. It's not just about wireless speakers, and certainly in the future, you're going to see a lot more diversification there. In smart buildings, the use cases have historically revolved around efficiency and security, now increasingly safety again. We can use presence detection here, facial recognition, voice biometrics to enhance security, but we can also optimize the energy footprint of our buildings and the utilization efficiency of meeting rooms, for example, by understanding where people are and how many people are there. Of course, in today's world, we're also now concerned about how we interact with that environment, and specifically whether or not we use touchscreens and the like. There's an increasing emphasis on contactless interfaces. So once again, voice has its part, a very strong position in the smart building. Smart cities share many of the attributes of smart buildings. Significant efficiencies can be gained through the understanding of the flow of people and traffic. Not just efficiencies in time, but also even the benefits of directing traffic to, for example, parking spaces that are available on demand, so that we save a tremendous amount on fuel combustion whilst people drive around currently looking for parking spaces. So there's very, very strong value propositions in the smart city, as well as the ability to manage individual security, either passively through monitoring environments, or actively through providing some interactive support. And this is, I guess, a somewhat more trivial example of somebody not knowing how to find something, but there are obviously more critical areas where support can be managed and security can be managed more interactively using artificial intelligence at the endpoint. Again, contactless interfaces. This is another shared environment, so contactless interfaces will play a major role here as we become increasingly concerned about hygiene risks in shared spaces. And this is the last example. There could be many more, but I think this is a great example, and I think the subject of a number of talks later on is the smart factory industry 4.0. Efficiency and safety benefits are obvious in a factory context, and we can use predictive maintenance, looking at various artifacts of machines in operation to determine whether or not they need to be maintained. We can use defect detection on the production line for higher throughput and quality. Human identification and presence detection, again, looking after people's security and safety in the presence of industrial plant on the factory floor. And of course, natural language interfaces can increase ease of use in this context as well. So we could go on. I've not got a slide on automotive, which is another one of those areas where there's obvious benefits. The point here is the application space is huge and fragmented. So lots of opportunities, but many challenges and some barriers to real explosive growth in this sector. Now, this is a comment. This set of responses relate to artificial intelligence and endpoint devices, but not so much necessarily to where that intelligence is delivered. And I think a lot of these responses reflect perhaps a bigger issue with the intelligence residing in the cloud. Of course, data security is always a problem, always a concern. We're gathering enormous amounts of data with increasingly complex and capable sensors. And we care about how that data can be used. Of course, that's quite natural, and that's on a personal level, but obviously also on a commercial level. So the community that we surveyed, they care about bandwidth, so slightly closer to home, perhaps, thinking about the technical challenges with all of those sensors producing an enormous amount of data. You know, how does our network scale to transfer that data to the compute resource? How long does it take if we're controlling the interactions of humans with machines, and more critically controlling the behavior of machines that might move? Then latency is extremely important. We want to be able to guarantee a response in an appropriate amount of time. For a human being, it might be a quarter of a second. For a machine, it might be milliseconds, or possibly even microseconds. And then there's scalability. You know, scalability touches a little bit on the bandwidth point, but also the scalability of compute. A lot of this technology requires enormous amounts of compute, and can we deliver it? Can we deliver it using the existing sort of centralized model? So moving intelligence to the edge solves for many of these challenges, but actually raises some new concerns at the device level. So people that develop devices and develop semiconductors for endpoint devices, they have some familiar challenges. Power consumption is always one of the big ones, trying to reduce power consumption so that we can be battery powered, so that we can deploy these devices into the field under battery power for significant periods of time. We're always worried about design complexity, and the flip side of that coin is how long is it going to take us to get this product to market, because these markets tend to be very volatile. You need agile solutions and techniques to get those devices to market, to hit those demand curves. Always we're worried about bill of materials. I mean, never more so than in consumer, but there is all of these markets are concerned significantly with the cost. And then as we move intelligence to the edge, we're placing unprecedented demands on processing power at the edge devices. So all of these things relate to each other somewhat. Obviously, processing power, increases in processing power typically come hand in hand with increases in power consumption, design complexity, and BOM cost. So they're all related to one another. So the question is, whilst making these devices more intelligent has the potential to improve the competitive advantage of products and change the world as we know it, how do we solve for these very difficult challenges? How do we make sure that we can continue this march towards delivering these genuine benefits across our society? So one of the things that was clear amongst our respondents was we need to reduce our reliance on the cloud. I think 70% of them agreed that more on-device intelligence is needed. So that really validates amongst the engineering community that there is a huge market for intelligence at the edge. It is one that's very fragmented. It requires massive increases in processing power, but not at the expense of power consumption or cost. So it's a bit of a challenge, and this is where this is really, you know, on our front yard as a semiconductor company. And our conclusion when faced with those challenges was that we needed a new kind of processor. And this is my opportunity for a shameless plug. XCORE AI is a third generation of our XCORE processors. It's a design, a technology that we own, that was designed by the University of Bristol. We originally designed XCORE to tackle the challenges of the Internet of Things. So the Internet of Things is a very fragmented space where you've got lots and lots of different applications communicating with each other through the internet. So we built a very high performance controller that had the ability to execute all of the control features, and uniquely also to address many of the challenges of connecting to different sensors and different actuators and so on in that space. In the second generation, we added signal processing to improve our capability of processing sensors, processing audio data streams and other data streams from different sensors. And finally, in our third generation in XCORE AI, we've increased the level of performance in every one of those areas, but also added artificial intelligence capabilities. So now we have XCORE AI, which is the only device that allows engineers to define their whole AIoT system in software, which tackles both the performance demands, but also the compulsion to get to market quickly and adapt in a rapidly evolving space. So we solve for all of the challenges that we've looked at. The level of the 4 classes of compute on XCORE AI allow us to integrate many of the discrete components that you would normally find and optimize the BOM. Since the inception of XCORE, we've always had the lowest latency of any microcontroller or microprocessor on the planet. We deliver low energy. We have a root of security that delivers privacy and so on. But critically, what we did with our latest generation of products is really push the accelerator pedal on performance. So we're delivering 32 times the AI performance, for example, of a Cortex M7 processor running at 600 megahertz, which is the sort of contemporary comparison point. So XCORE AI is a real beast. It's designed addressing the concerns of that were echoed very strongly in that survey, for a device that's very economically available to those engineers to help them to solve the challenges that they're facing. So this is my last slide. Hopefully, we're all observant of the impact that artificial intelligence is having in our environment already. But I think we're reaching a tipping point. I think COVID is a catalyst for that. And we'll see that not just in convenience, but also safety and security, we'll see real impact in the future from deployment of intelligence at the edge of the network. It depends on numerous players in the ecosystem stepping up and delivering solutions that are cost effective and secure, that don't rely necessarily on cloud connectivity. They may be augmented by cloud connectivity, but they don't rely upon it. And I'd invite you to come and see us at XMOS.ai to learn more about XCORE AI, which is a truly distinctive product that is absolutely targeted and tuned and tailored for this space. So that's me. If you want to know more about the Edge of Tomorrow report, it is available on our website, and there's more detail there, as well as all of the statistics and questions that were put to our audience. Finally, thank you very much for the opportunity to talk.